and I will post this video on Canvas after this class. I do the downloading and posting, so it'll be up there about 12:30. So if you missed something, or if there's parts of this you want to rewatch, if you want to share it with your friends because it was such an amazing experience, then it'll be up on Canvas a little later. All right, section 1.1, this is where we're starting today. Like I said, I'm hoping the goal in starting this class with this particular section is, I'm hoping this is a foundation that we all, it seems familiar, we feel pretty comfortable, and if it's not super comfortable, it's hopefully nice to get caught up. What we are going to do here is we're going to do what's called solving linear equations. If you're fond of solving equations, great. Then you're just going to tag along with us as we get started, and we'll get rolling into this class. Okay, so the first thing where I want to start is a difference between two things, because sometimes we make an observation mistake when we first get into algebra. So here's two examples. Let's say I have this 3x minus 7, that's something, and then I'm going to leave a gap. This is a separate something. 3x minus 7 is equal to, let's keep the numbers relaxed, 14. One of those is an equation and one of those is not. Which one's the equation? The one on the left or the one on the right? Okay, one on the right. What makes the one on the right an equation? Perfect. There you go. Has an equal sign. Okay, so when we talk about equations, we're talking about things with an equal sign. Okay, I know that might seem like something super simple, but sometimes we use the wrong words when we're talking about equations versus what that thing is there. And we'll talk about that in a minute. When you see an equation, the thing we are going to do most often with an equation is we are going to solve equations. What solving is, again, if you know this, beautiful. If you don't, that's why I'm going through this. I don't want to make too many assumptions. When you solve something, what you're doing is you're finding the value of the variable that creates a true statement. So when you solve, what I'm asking you to do is I'm asking you to take this equation, and we're going to learn how to manipulate it so that I figure out what the value that goes into that little spot is that would create a true statement. That value also is called the solution. We're going to solve different types of equations over the course of this semester. We're starting with linear equations. We're going to talk about quadratic equations, rational equations, radical equations. We're going to have a super fun time solving different things as we go along. Okay. That's an equation. Now, this thing right here, we're going to encounter stuff like this as we go along the way. This is called an expression. And what we do with expressions is we manipulate them. Okay, so in different situations, you're going to learn how to manipulate them. So, for instance, we might evaluate an expression, which means to plug in a value. We'll talk about that at some point. We might simplify an expression, and we'll do some of that today. Things like combining like terms and distributing and factoring. Those are all things that help us simplify. And there's other things. I'm not going to bore you by listing all the things we do with expressions. Okay? But we don't talk about solving an expression. That's why I'm going to this great lengths. Okay, that's sometimes verbiage that a student uses that I think you know what you're talking about, but you're not expressing it correctly. So I want to make sure that we're doing that. Questions so far? Anything controversial or anything causing you any sort of consternation right now? Okay, so specifically, we are solving what's called a linear equation in this section. So what does it mean for an equation to be linear? Linear equations are those that the highest power on the variable is 1. We don't have any squares or cubes. We don't have any fractions involving variables. So there's no variables in the denominator. It's just nice and neat and pretty. We've got just a plain old x in our equation. I know that you got, in my math lab, there's a fantastic ebook. Okay, you don't get the printed book, but this book is available, and I was looking through it I was looking through the ebook for a different class on my math lab. It's set up, it's really easy to access. Some of the examples are like live examples where things will be worked out. They're interactive. So if you ever want to click around in the book a little bit, go ahead. But the reason I mentioned the book is just because I've got to write some things up here that I want you to be familiar with. So the standard form of a linear equation, we can put any linear equation into this form right here. And so all I'm going to do is I'm going to take this. This is a linear equation. I'm going to take this, and instead of having numbers, I'm going to replace it with letters. Okay, it's just more general. So the standard form is AX plus B is equal to C. Just some terminology. Again, I'm just trying to make sure that we're all in the same place. The X is called the variable. That's the thing we don't know. That's the thing that we can change the value of. And then in this thing, the A, B, and the C, these are just constants. Like in this example, the A, B, and C are 3 and negative 7 and 14. So any linear equation can be written in that format. Again, I'll ask you, so far, so good. All right. When you have a question, comment, concern, conundrum, please let me know. Okay, so now what we're going to do, we're going to spend the rest of our time today solving equations. There are 2 tools that we have to solve any linear equation. So I'm going to start with the most simple possible example, and then we're going to quickly work our way up. Okay, I'm starting simple just because I want to make sure that we're comfortable with the 2 things at your disposal to solve linear equations. So first, what we're going to do is we're going to solve this equation right here, and you're going to help me. So we want to solve x, let's say, plus 8 is equal to 13. This is probably the simplest. Now, simple doesn't mean easy, but this is the simplest linear equation that you can possibly solve. So what it means to solve is I want to create a new equation that's less complicated. That just tells me the value. I want to create an equation that says x equal to the solution. So that means I got to get the x alone. So first thing, as I observe this, if my goal is to get this x, this thing right here alone, what has to be moved? The 8. Okay, how would you guess, am I going to take this plus 8 and move it over to the other side? What am I going to do? Great, you guys are all where I need you to be. Fantastic, I love it. Now, one thing about this class, okay, you're going to do me a favor, and if you have me for college algebra, you won't have to do this. But again, I'm trying to get you to the place you need to be. I keep the numbers fairly simple here. I'm not trying to tax you. I'm not trying to make you hate me, but I do want to see the work, okay? This works in your favor because when you take the test, you show me the work and you just make a goofy arithmetic mistake because it's a test and you feel stressed. I understand. Well, I can give you partial credit, right? But if you don't show me any work and you end up with the wrong answer, I got to mark it all wrong. Okay, so you're going to show me some work. Okay, this is how I like the work to look, but if you had a different class and your work looks different, I'm comfortable with that. Okay, so I'm subtracting 8 from both sides. This is called the addition property of equality. I know we're subtracting, but it's just another form of addition. It's called the addition property of equality. What it says is that the equal sign's like a scale, and if I add or subtract something from one side, then I have to add or subtract the same thing from the other side to keep it in balance. Okay, my equation is all about balance. So on the left side, what happens with the 8 minus 8? They cancel, and I just have x. My equal sign always stays in the middle, and then 13 minus 8, your calculator can tell you 5. The last thing I want you to do, this is a notational thing. I want to try to help you develop good notation so that when you get to college algebra, and I expect this from you, the things that we solve represent sets of answers. Some equations are going to have lots of answers. Some are going to have one, like this one. So we're always going to write our answer as a solution set. So we're going to use some squigglies. They're called braces. These are not parentheses. These are not brackets. These are squiggly braces. Okay, that means a set. That's my solution set, a set with 5 in it. All right, here's one for you. Try this one. Let's say that we have y minus 9 is equal to negative 4. Solve that, write your answer as a solution set, please. So once again, I'm thinking in terms of my goal. My goal is to get the variable, the y by itself. So help me. What do I have to move if the y has to be by itself? The 9. This time, what am I going to do to get the 9 over there? Perfect. You guys are doing great. I'm really happy. So this time, the -9 plus the 9, that cancels. It leaves me y. My equal sign stays in the middle. Your calculator tells you -4 plus 9 is 5. Oh, I'm not creative. See, I told you. Got the same answer both ways. That's the first thing. That's the addition property of equality. Here's the second tool that you have at your disposal to solve linear equations. So it's something like this. Let's say that I have 4x is equal to 36. Now a notational thing. Okay, again, I'm assuming you know this, but just in case you don't, when I have a number and a variable and there's no symbol written between them, what operation am I assuming? Yeah, multiplication is implied. Great. So this time, again, I got to get my variable by itself. I got to move the 4. How am I going to undo multiplication? How do I get the 4 over there? Great. You're just doing the reverse, both ways. Okay. The reverse of subtraction was adding. The reverse, the first example of that, I don't even know what I'm saying anymore. Of adding was subtracting, and now the reverse of multiplying is dividing. Great. What's 4 divided by 4? Not 0, it's 1. Okay. Now you can write this. I'm not fussy about this in this class as we're learning our notation. You can say 4 divided by 4 is 1x. That's great. I don't care. I'm not going to write the 1. It's implied. So goodbye. So when you don't see a number in front of the x, the 1 is implied there. And then 36 divided by 4 is 9. I failed to mention, I don't do this in here just for time's sake, but you can always know if you got the problem right or not. All you got to do is take the value you got, your solution, plug it back in. 4 times 9, 36. Okay. Again, I keep the numbers pretty simple most of the time, okay, but it never hurts to check. Here's my solution set. All right, here's the last simple equation, last one-step equation for you. Let's say that you have -5x is equal to, let's go, something like 40. Okay, so I've got to move what? What needs to be moved this time? -5, right? So how do I undo the -5 in front of the x here? Divide by? Perfect. Use the word that I was hoping. When we divide by exactly what's there. Okay, so not the opposite, because a negative divided by a negative is a positive. Okay, perfect. Okay, so negative divided by negative is +1. 40 divided by -5, your calculator is going to tell you it's -8, and there's my solution set. Okay? Are we still all on board? We're doing all right. Okay. We're moving our way up then. So let's go back to that linear equation I started our discussion with. I think it was 3x minus 7 is 14. We're going to solve this one now. Well, again, my goal is to get the x by itself. But before I can get the x by itself, I need to get this term by itself. So what has to be moved first? Yeah, let's do all of our adding and subtracting first so that we get that term by itself so that we have a problem that looks like this to end with. So what I'm going to do is I'm going to add the 7 to both sides. Okay, that's the addition property. -7 plus 7, boom, I have 3x on the left. My equal sign stays in the middle. 14 plus 7 is 21. Last step. Yeah, it's always going to be our last step. Divide by 3. And then 3 divided by 3 is 1x. 21 divided by 3 is 7. And that's my solution set. I put some squigglies around it, and there it is. I neglected to mention, I apologize because sometimes I get super excited. This is called the multiplication property of equality. I know it's division, but division and multiplication are related operations. Says similar thing to the addition property. It says if you're going to keep your equation in balance, you got to make sure you multiply or divide both sides by the same thing. And that's what you have to do. Here's a problem for you. Same sort of thing. Remember, if you have a question, if at any point there's something that is not as obvious to you as I'm hoping it is, please feel free to ask what you need to ask. So let's say that we have 2x plus 7 is equal to 25. All right, what's step one? Yeah, in order to get the x by itself, I got to get this term by itself first, okay? By the way, the nice thing about this is once you get the pattern, solving linear equations is always the same thing every time, okay? So it's just a matter of doing enough so that it becomes second nature. So I've got to subtract the 7. I got to get the x term by itself. So when I do that, 7 minus 7, those cancel. I'm left with 2x. My equal sign always stays in the middle, and your calculator will tell you 25 minus 7 is 18. Great. And step number 2. All right, so after this problem, we are going to do the most difficult linear equation that I can possibly give you. Woo-hoo-hoo. That sounds exciting. So my solution is 9 right there. So here it is. I know now you're waiting for it. You're regretting being in this class, I'm sure, at this point. Here is the most difficult linear equation that I could possibly give you to solve. Okay, 8x plus 6 is equal to 5x minus 12. If you can do this one, you can do any linear equation. I've got x's on both sides. I've got numbers on both sides. Okay, so there's something going on everywhere. So my goal here is the same. I want to get the x by itself. So here's what we're going to do. This is our general procedure. We're going to get the x's on one side. We're going to get the numbers on the other side. Now, Hertzter, what side should I put the x's on? It really does not matter. But I have the pen. I'm an x on the left kind of guy 99% of the time because 500 years ago when I was in algebra, Miss Hilliard, she demanded it. Okay, she was a stickler for your x's are on the left. So I'm broken now. So I'm going to get my x's on the left. So if I'm going to get my x's over here on the left side, what do I have to move? How am I going to move the 5x over to the left? Perfect. We're going to subtract. Wonderful job. Yes. I'm going to do these one step at a time because I don't want to confound anyone. So 8x minus 5x, that's 3. Like terms, that's one of the things I assume you know how to deal with. So if combining like terms is something that looks unfamiliar to you, we should talk after class, okay? And find a way to get you up to speed on that. I've not done anything with the plus 6 yet. My equal sign stays in the middle. I've canceled the 5x's, and what's left over there is the negative 12. Remember, the sign is always in front of your term. Okay? Now it just becomes the problem we did before. I'm going to move the 6 now. So I've got 3x. My 6's cancel. My equal sign stays in the middle. Your calculator will tell you that a negative 12 and a negative 6 is negative 18. Last but not least, I divide by 3, and I get that my x value is negative 6. There we go. And there's my solution set. Before I move on, I don't want to just rip through this and assume everything. Are we okay? Question, comment, or concern? Anything I need to know? Okay, here's one for you, just like it. Okay, 9x plus 1 is equal to 7x minus 9. I'm going to do this by getting the x's on the left. If that's not your gig, if you learned it differently, great. Remember, we will end up with the exact same answer. Sign same, value same. Okay, you should get nothing different. Hey, if you're not quite done, I apologize. I just try to split the middle between those who are super fast and those who are not. There's nothing wrong with either way. Okay, I'm just trying to keep things rolling. So here we go. I'm going to deal with my x's first, although you can deal with the 1 and the -9 first. It doesn't matter. The order is immaterial. I'm going to get my 7x over onto the left by subtracting it. Just as an aside, in case anybody did this, if you brought the 9x over here, you subtracted 9x. Okay, that's fine. It's a perfectly legal and wonderful thing to do. 9x minus 7 is 2x. 7x is cancel. I've got -9. I'm going to bring the 1 over to the right. Whatever you do, I just recommend doing the same thing every time. That way, when the test comes and you're looking at it, you've done the same thing every time, 30 or 40 times. So it's not a big deal to remember what to do. So we've got 2x, the 1's cancel, the equal sign stays in the middle. Your calculator will tell you a -9 plus a -1 is -10. And divide by 2, we get -5. Are you still tracking with me? Doing all right? Okay, that makes me happy. I hope you're telling me the truth. I assume you are. Let's try this problem right here. 4x minus 2x minus 5. On the other side, we've got 4 plus 6x plus 3. I'll give you a moment to write that down. So now you're thinking, hey, Perkster, you lied to me. That looks harder than the previous problem. Well, what I said was, as far as the previous problem, that was the hardest the solving could be. The solving here is no different, but what we need to do, what you're noticing, is that I can make this look a little nicer. So forget solving. We're not moving anything across the equal sign just now. We're going to make this look a little nicer. I'm going to cover up the right side of this equation. When I look at just the left, what can I do over there to make that look a little nicer? Yeah, I can combine those like terms, right? So the 4x, I'm just going to underline it, the 4x minus the 2x. I can perform that operation. If anyone does not know, remember, talk to me after class. Like terms are things that have the exact same variable part. Okay, it's just counting. So if I have 4 of something and you take away 2 of them, then I'm left with 2 x's. Notice I did not do the opposite. I did not add 2x because they're on the same side already. Sometimes that is a mistake students make. So if you were tempted to like add 2x, they are on, make a little note to yourself, they are on the same side. I'm just collecting like terms. I've not done anything with the -5. My equal sign stays right there. Now let's look at the right side of the equation. Do I have any like terms over there? Yeah, the 4 and the 3. 4 plus 3 is 7, so I've got 6x plus 7, or 7 plus 6x, whatever order you would have written those in, it doesn't matter. That's the only new part. Does anyone have any questions about how we got from here to here? Then as promised, this is as difficult as the actual solving gets. Now I'm going to move my stuff around. So I'm going to put my x's on the left, I'm going to put my numbers on the right. So x is on the left, I'm going to subtract 6x. 2x minus 6x is -4 of them. I've not done anything with the 5 yet. The 6x's cancel, and I've got 7. Same thing every time, just different numbers. I'm going to add 5 this time. This is step number 2. -5 plus 5 cancels. 7 plus 5 is 12. And then last but not least, 12 divided by -4, positive divided by negative is -3. And there's my solution set. Did I lose anybody there? Here's one just like that for you. Same sort of thing. So it is 4x plus 8x plus 25 is equal to -9 plus 17x minus 1. So I'll give you a minute or two to solve that. All right, so I'm going to get started. If you're working, still work, that's fine. We'll compare notes at the end. If you got something different and you don't see why, let's talk about it. Okay, so just ask a question. So left side, I've got some like terms. I've got this 4x plus this 8x. So I'm going to combine those to make this look a little better. That turns out to be 12x. I've not done anything with 25. There's my equal sign that stays in the middle. On the other side, I've got no like term with the 17x, and then the -9 and the -1 is -10. Questions, comments, concerns? We okay? Same thing, right? X is on the left, numbers on the right, then I'm going to divide. So I'm going to subtract my 17x. 12 minus 17 is -5x. There's my plus 25. By the way, I know a lot of you, probably all of you, solve linear equations. If you can do both of these steps, at some point in the future, I will do both steps at once to save a little ink because these markers are expensive. So you can combine them, that's totally fine. But I'm just trying to keep things separate, just in case anybody here is getting up to speed. Maybe it's been a while since you've done some algebra. I'm going to subtract my 25. Got a -5x. The 25s cancel. -10 minus 25, -35. And last but not least, I divide. And a negative divided by a negative, 35 divided by 5 is 7. It's positive. Still feeling all right? Because I'm going to move to the next thing. Okay, just showing you, I'm showing you a little bit of everything you're going to see on the homework. Okay, so hopefully when you go tonight and register for my math lab before you go to sleep, and you maybe do a few homework problems, I'm hoping that everything will look super familiar. You'll be nice and confident. You'll ace the first quiz, and all will be well. That is what I'm hoping for everyone when you leave here today. So let's try this problem next. I'm going to actually just ask you a question about it. Then you are going to do the problem. So it goes like this. Let's say that I have 2 times x minus 5. And then I've got plus 3x is equal to x plus 6. So I'll give you a moment to write that down, then I'm going to have a question for you. So we see something new in this problem that we haven't seen in any of the others. I got these parentheses. So clearly I want to get rid of those parentheses. Does anyone remember how to do this? What the word is for what I'm going to do to get rid of the parentheses? You're going to distribute. And all distributing means, in case you're unfamiliar with that, is I'm going to take this 2 and I'm going to multiply by each of the 2 terms inside this parenthesis. And then once you've done that, it's going to be a problem just like all the other problems. So give it a try. Okay, so let's get on with this problem. First thing you told me before we had some silence there was I need to distribute. So when I distribute this 2, what's my first term going to be? Remember, there's a 1 in front of there. So 2 times 1 is 2. What's the second term going to be? -10. Great. Do I multiply the 2 times the 3x? Why not? Well said. Not in the parentheses. Got some like terms? 2 plus 3 is 5. Going to subtract the x. I'm running out of room, so I might try to do both things at once. If this confuses you, let me know, and I'll stop being lazy, and I'll use the eraser. 5x minus x is 4x. The equal sign stays in the middle. These x's cancel. I'm going to add the 10 to move the 10 over there, so plus 10 on both sides. So the 10s cancel, and 6 plus 10 is 16. And then I'm going to divide by 4. And we get x is equal to 16 divided by 4 is 4. That's my solution set. Everybody follow along with my work? Don't want to unintentionally lose anybody by being lazy. Here's another one. Same sort of thing. I do have a purpose for asking this question, so we'll see how you do with it. And if you make the mistake that sometimes is made, remember, don't shame yourself, don't beat yourself up, just learn. That's all this class is about. So that's what I'm hoping for. So 2 minus 3, and then I've got some parentheses. 2 plus 6x equals 4 times x plus 1 minus, or no, plus 36. Give you a couple minutes to sort through all that. Yeah. Oh, I'm sorry. No, okay, that is a question you never have to ask. You can go ahead and be free, so definitely. That applies to anybody else. Sorry that I missed you. Just always just scream out. Perkster, what's up? Why don't you see me? So the reason I ask this question is sometimes the way this is written causes a little bit of conundrum on the left. Okay, so I need to distribute or I need to subtract. So sometimes this is not as obvious as I'm hoping. So remind me, order of operations in arithmetic. What comes first in my order of operations? Multiplication or subtraction? Yeah, okay, multiplication. Order of operations is you start with your parentheses, then you do your exponents, then you do your multiplying and dividing, then you do your adding and subtracting, if you remember your arithmetic. So the reason I give this problem is sometimes this 2 minus 3 catches people's eyes, And you're tempted to say, oh, 2 minus 3, don't write this down, this is wrong. 2 minus 3 is negative 1 times 2 plus 6x. So if you did that, there's nothing wrong with you, okay? But the reason I'm doing this is I don't want you to do it again, okay? Multiplication comes before subtraction. So what I need to do is I need to do that distributive property. Okay, so the first thing I'm going to do is I'm going to distribute this negative 3 through the parentheses. So the 2, I'm not doing anything with the 2. Negative 3 times 2 is negative 6. And then negative 3 times 6x is negative 18x. On the other side, the way the other side's written, it doesn't fool us at all. I'm going to go ahead, 4 times x is 4x. 4 times 1 is 4, and then I've got that plus 36. And again, this problem is just like all the others that we've been doing at this point. I'm going to collect these like terms that I've gathered here, and then I'm going to solve. So 2 minus 6 is negative 4, minus 18x. Then I've got 4x, and then 4 plus 36 is 40. X is on the left, numbers on the right, so I'm going to subtract my 4x. So I've got negative 4, negative 18 minus 4 is negative 22. My 4x's cancel, and I have 40. I'm going to move the 4 over because that's the term without the x, so plus 4. I'm going to write my result on the top of the next side. So the negative 4 plus the 4 cancels. So on the left, I have negative 22x. My equal sign stays in the middle. And on the right, I have 40 plus 4 is 44. And last but not least, what the answer we should all be looking at is 44 divided by negative 22 is negative 2. We're still doing okay. You're almost there. You're almost surviving your first day. Then we've just got 23 more. Okay, so you're doing a great job. We just got a couple more problems with whatever amount of time. The clock in the back doesn't work yet. We still got a half hour. We're doing great. So here's my next example for you. It is x plus 7 over 6. Uh-oh, heart rates all over the classroom are going up. Plus 2x minus 8 over 2 is equal to negative 4. All right, so we've got fractions. We're encountering them for the first time today. So this is still a linear equation, notice, because the powers on the x are still 1. I don't have any x's in the denominator. That's something completely different. We talk about that in the 4th unit of this class. Okay, so I've not violated anything. So what I want to do, and I'm guessing what you probably want to do, and the whole reason for this problem is I want to practice some fraction avoidance. Okay, I would prefer not to deal with fractions if that's at all possible. So what we're going to do, and we'll use this again as we go into different units in the class, is what we're going to do is we are going to clear the fractions. What my goal is I want to create an equation. The next equation I see right here, I want to have no fractions at all. Okay, that way I can feel more comfortable, my blood pressure goes down. So the way we clear fractions is this. Okay, this is the process. We are going to multiply every term. I'm going to underline the word every by the least common denominator. So that begs the question, okay, because it might have been a while since you've used fractions or practiced with them. Okay, finding the least common denominator. So least means the smallest, common means something they have the same, and the denominator is going to be whatever multiple that these two things have the same. Now, I don't have time to go into great detail about finding least common denominators, So if this is totally, completely out of left field for you, again, see me after class. I got some resources I can share with you. But I do have a quick method that will work almost all the time. Okay, it might be a little bulky if the numbers are really big, but the numbers don't tend to be too tragic in this class. So here's what we're going to do. Here's my example for you. What we're going to do is we're going to find the LCD of this problem right here. And let's say that I have 1/4 plus 5/6. Let's say that's the problem we're asked to do. I need to find the least common denominator between those two things. Now I'm going to share a little math secret. They're going to take away my math teacher card because I'm not supposed to share this secret with anybody. You can use any common denominator in problems. You can just multiply 4 times 6 and get 24 and go on with that. It will totally work. The reason we choose the least common denominator is it keeps the number smaller, less reducing, stuff like that to have to do. So the method that I'm just going to show you real quick for finding a common denominator is called the listing method. Okay, so if you don't like to do this, or if you don't have a way to find the least common denominator, the listing method will always work. Okay, and it's low stress. All you're going to do for the listing method is you're going to take however many denominators you have. I got 2 in this case. And I'm just going to list the multiples until I find the first one that they have that they share. So what I mean by that, what I mean by multiple is this. 4 times 1. What's 4 times 1? Question we can all get behind. What's 4 times 2? 4 times 3. 4 times 4. And I'm going to stop there. I can always add more on. That's the beauty of the listing method. Okay, my work is not wasted. I'm going to do the same thing with 6. And then I'm going to stop when they have something in common. So 6 times 1 is 6. 6 times 2 is, oh, ding, 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 ding. There it is. There's the least common denominator, listing method. Okay, so that will work on every problem you're going to encounter in your home. I didn't use those denominators because these denominators are a little more obvious. I think if that's not true, then I apologize. What's the least common multiple or the least common denominator between 6 and 2? Okay, 6. Now again, if you said 12, sure, go ahead and use it. You're not going to be wrong. You'll end up in the right place. Okay, but 6 is the lowest common denominator. So here's how I'm going to clear the fractions. I'm going to multiply each 1, 2, 3 terms. I'm going to multiply each term by 6. So 6, I'm going to get 6 over 1. I'm going to move the plus sign here just so everything's not squeezed in. I'm going to have 6 over 1. And then I know this isn't a fraction. I know our temptation is to overlook this, but that's why I underlined the word every. I've got to multiply that by 6 as well. I'm going to pause because that's the hardest part of the problem. Okay. Anybody got a question about where we got the 6 from or what we're doing or why we're doing it? My goal is to have no fractions next. Okay, so if I have a fraction in my next thing, I have done something wrong. So let's see. All right, my first term, I've got 6 over 1 times x plus 7 over 6. What happens to the 6's? What's 6 divided by 6? 6 divided by 6 is 1. Yes, so they cancel. That's what we call that. That's good. No more denominator. That's what I want. So 6 divided by 6 is 1, and so I just have the x plus 7 left over. Everybody catch that? We okay? Okay. Second term. I've got 6 over 1 times 2x minus 8 over 2. What's 6 divided by 2? 3. So 2 goes into 6 and leaves 3. Now here's what I'm going to do. I'm going to make a little note of this. I've got a 3 right here times the 2x minus 8. What do I need to do with the 3 and the 2x minus 8? Not combine like terms. You're probably thinking the right thing, using the wrong word. We've already used this word with parentheses. I'm going to distribute. I've got to distribute the 3. It has to be multiplied by both those things. So I'm going to put a little asterisk here. Just don't forget to distribute. That's important. So 3 times 2x is 6x. 3 times negative 8 is negative 24. On the other side, negative 4 times 6 is negative 24. And lo and behold, lovely, I now have an equivalent equation. Okay, this equation and this equation are the same thing, but this one has no fractions, so it's more fun to look at. I'm gonna rip through the rest of this because we've done this 100 times already today. But before I do, anything that I went too fast through, anything that you're not tracking with here? Hope you're being honest with me. There's no one benefits from you not except you're only hurting yourself. So x plus 6x, that is 7 of them. 7 minus 24 is negative 17. I only have x's on one side on this problem, so I don't need to worry about the x's. So I'm just going to add the 17. 17's cancel. The equal sign stays in the middle. Negative 24 plus 17 is negative 7. And last but not least, it's always the last step. Divide. And there it is. I've got another problem just like this because I want you to work through the steps. So here it is for your algebra pleasure. I want you to solve this. I want you to clear the fractions. I'm going to use the lowest common denominator, but you can use any common denominator you want. So x minus 4 over 4 plus 2x plus 4 over 8 is equal to something 5. Just to nudge us in the right direction, what's the common denominator? What's the lowest common denominator you're using? Okay, keep working. I'm not going any further. I just want to make sure we're all working. All right, so 8 is the common denominator we're using. Once again, if you used 16, if you use 24, 32, you'll all end up in the same place I do. So the first term, 8 divided by 4, leaves me 2. The denominator goes away, which is what I want. So now I'm going to distribute. 2 times x is 2x. Let me make a little note for your notes. It's usually the most common mistake on this problem. People tend to be good at identifying the common denominator and knowing what to do with it. The 2 big mistakes are forgetting to distribute and also forgetting to multiply the non-fractional term by the common denominator. 2 times negative 4 is negative 8. This fraction right here, 8 divided by 8 is 1, so that just leaves me 2x plus 4, the numerator, and then 5 times 8 is 4. It's a difficult step. I understand it takes some getting used to. If we have time, I'd like to do one more fraction problem, but I've got one other thing I got to tell you about between this and one more of these. So finishing this up, 2x plus 2x, that's 4x. Negative 8 plus 4 is negative 4. I'm going to add the 4 to both sides. 40 plus 4 is 44. And last but not least, I divide. And I end up with x is equal to 11. That's my solution set. And I feel great. All right, so before one more example, time permits, I just got to give you a little bit of final terminology about equations. Every equation that we have solved, every one of them since the very first simple equation has been what's called a conditional equation. A conditional equation comes up with a solution. What this means, for instance, for this equation right here, the reason it's called a conditional equation is because this original thing I started with is true under this condition, that x equals 11. Okay. That's why it's called a conditional equation. This equation right here is true under the condition that x equals negative 1. So it's called a conditional equation because the solution is the condition that creates true statement. That's the most common thing you're going to see throughout this class, but there are 2 other types of equations. I just want you to know what to do with them when you encounter them. So I'm just going to give simple examples because I just want you to know what to do, what conclusion to make. So here's the first example. Let's say I have 2 and some parentheses and x minus 5. And on the other side, I have 2x plus 7. So I give you this to solve. It's a homework problem. It's on a quiz. Maybe throw it on the test. Solve this. All right, well, just going to do what we've been doing. I'm going to distribute. So 2 times x is 2x. 2 times negative 5 is negative 10. I'm going to put all my x's on the left. I'm going to put all my numbers on the right. Okay, so when I go to put all my x's on the left, what am I going to do to get this 2x over to the left? I'm going to do what? Now, here's the thing. This is why this is a special situation. What happens when I subtract 2x from both sides? Yeah. Okay, so you haven't done anything wrong, but the x's over here cancel as well, right? 2x, so we have the same x term on both sides. So what this leaves now is it leaves me negative 10 on the left, 7 on the right. Is there any x term? Is there any variable? Is there anywhere to put a number and create a condition? So what's the conclusion? What happens? Well, is this a true statement or a false statement? Is negative 10 equal to 7? Oh, that's false, right? Will that ever be true? Is there any way, any condition that I could make that true under? No. So this is always false. So what this is called a contradiction. What this is telling you is that there was no condition under which the original equation was true. It can never be true. So a contradiction has no solution. And this is for your information. On the test, when I give you the test and I ask you to solve this, what I want is the solution set. You're going to give me the solution set. Well, if it has no solution, then it is what's called the empty set. There's nothing in it. There's 2 ways to write the empty set. I like to just use a pair of squigglies with nothing in between, empty set. Or, I know some of you have had algebra and you've had a teacher that likes to use the null symbol, which is like a olive with a toothpick through it. It's the null symbol. Both of these things mean empty set. Pick your favorite, forget the other one. Don't use both. More is not better. Okay, if you do both, is that set empty anymore? No, it's got a goofy symbol in it now. Okay, so it's not an empty set. That's wrong. Bad notation. Okay, pick your favorite, go with it. Contradiction. When you get a statement that can never be true, it's a contradiction, no solution. The other type of equation that you can have is, let's say that I have 5x plus 8 is equal to 5x plus 8. So let's say we had a bigger equation and we've simplified things and we've distributed and we've collected like terms, and we end up with this. And let's just pretend you don't notice that you got the exact same thing on both sides, and I'm going to get all my x's on the other side. So I'm going to subtract 5x just like we did over there. And once again, my x terms go away, okay? But this time, I'm left with an 8 on the left and an 8 on the right. Or in general, I'm left with the same thing on both sides, whatever the number is. Well, conclusion. Is this a true statement? Yes. Is there ever a condition where this will not be true? 8 is always equal to 8. There's no other terms here, right? So this is always true. The math term for this is identity. What the identity tells you is that it doesn't matter what x's you picked at the beginning, every x would work. Okay, so the solution set for this is all real numbers. So up to this point, when you're doing your My Math Lab homework tonight, because you've registered before you go to sleep and you've gotten yourself going, for right now, they're going to give you a little button that you can select for all real numbers. When we come back on, when we come back on Thursday, I'm going to teach you how to write all real numbers mathematically. Okay, so for now, though, that's what you have. So how do you write that as a set? That is something that is to be determined. We'll talk about that on Thursday. That's all the new information. I got one more example because we've got 14 minutes left of class, so you're still going to get out a couple minutes early, but we're going to do one more example. But before we do that, is there any question about any of this, anything we talked about, anything that I've not been clear on? Remember, practicing will get it into your long-term memory. That's where we want it to be, so that when test day comes, test day is the best day. All right, the reason I want to do this example is because there's a sign in here with the fractions. I just want to make sure that when we encounter this, when I'm not around, you feel comfortable in knowing how to deal with it. So here is our problem. It's 3x plus 2 over 7. This time, instead of plus, there's a minus sign right there, so be careful. Then I have x plus 4 over 5, and that's going to be equal to 2. Let me give you a couple minutes to chew on that, make as much progress as you can, or get to that point where you maybe you don't know what to do next. That's okay. That's an opportunity to learn. Again, just to nudge us in the right direction, what's the common denominator you're multiplying by? Okay, 35, yes. Keep going. All right, so my biggest concern here is twofold. Again, just want to make sure you're comfortable clearing the fractions. So that is challenge 1. Okay, challenge 2 is what to do with the sign. So if you cleared the fractions well and you just didn't do the right thing with the sign, that's a victory. Okay, so just take this opportunity to see make sure you know what to do with that minus. So we'll get there. So here you told me let's multiply everything by 35. So this first one, what's 35 divided by 7? What does that leave me? Okay, 5. So I will distribute that now. So 5 times 3x is 15x. 5 times 2 is 10. So far, so good? Here, what's 35 divided by 5? Okay. Here's the key question. What am I multiplying? What am I distributing times the x minus, the x plus 4? Okay. The 7 is what's left over, but then I've got that minus sign. So you're exactly right. Don't forget that those go together now, and I'm distributing the negative 7. Okay. So negative 7 times x is negative 7x. Negative 7 times 4 is negative 28. So again, let me reiterate. If you got plus 7x plus 28, if you didn't know what to do with the minus sign, it's okay. Okay, this is all about learning. That's why I did the problem. But if you cleared the fractions, that's great. Happy. On the other side, 2 times 35 is 70. I will finish the rest of this up. I think we're in familiar territory now once we've cleared the fractions. 15 minus 7, that's 8x. 10 minus 28 is negative 18. And then I add the 18. And we get a lot of 11s as our answers in this. And there it is. There's my solution set, because I love good notation. And that is the end. So I'm going to stop the recording. If you got a question, ask it. We're 10 minutes early here. I'm gonna give you the gift of a few minutes.